Hi, welcome to Supplementary Lesson 16a, where we're going to examine tangents and normals and their equations for derivative techniques and functions that perhaps were not investigated earlier in the course. Okay, so let's start off with finding the equation of the tangent and the normal to this function, f of x equals root x, multiplied by 1 minus x all squared at x equals 4. Well, when we look at equations of tangents and normals, we realize that those two functions are linear. And to find the equation of linear functions, we need a gradient and a point. So what I'm going to do is I'm going to evaluate f of x at x equals 4 because I need to know the y coordinate of that point. So right over here, I will evaluate f of 4, and I'll just substitute 4 into the equation. So we get 2 multiplied by negative 3 squared. Negative 3 squared is 9 times 2 gives me 18. Therefore, the point that we're going to be looking at is 4, 18. And I will rewrite this, because of that square root sign, I'll rewrite this using powers. So I'll have x to the 1/2 multiplied by 1 minus x all squared. And then now I will take the derivative of this using the product rule, because I've got two functions, x to the 1/2 multiplied by 1 minus x squared. So the derivative function then, or the gradient function as it were, will be 1/2 x to the negative 1/2 multiplied by 1 minus x squared, plus, now the derivative of the second part of it, 2 times 1 minus x multiplied by negative 1 multiplied by x to the 1/2. So what I'll do now is I'll just clean this up a little bit, do a little bit of simplifying. So the first part I'll just kind of leave the way it is, 1/2 x to the negative 1/2 multiplied by 1 minus x squared. And then I'll bring this negative 1 to the front with the 2 and the x to the negative, or x to the 1/2. So I get 2x to the 1/2 multiplied by 1 minus x. And now just to simplify things a little bit, I'm going to factor out a 1/2, x to the negative 1/2, and a 1 minus x. And I think, yes, I made a little mistake there, and I apologize now that I see it. That should not be squared. I need to make this, there we go, that's supposed to be squared. Okay, there we go. So I'll factor out the 1/2, x to the negative 1/2, and one of those two, 1 minus x's. And then I'll be left with the other 1 minus x minus 4 and x. And then I'll just leave 1 minus x times 1 minus 5x all over 2 times the root of x. Okay, so now we're set. So that is the derivative function, or the gradient function. And to find the equation of the tangent and the normal, I'm going to need the gradients of both the tangent and the normal. So the gradient of the tangent is the gradient function evaluated at x equals 4. And then I'll substitute in the 4 where it belongs in both of these places. And so we got negative 3 multiplied by 1 minus 20 is negative 19 all over 4. And that gives us then 57 over 4. So that's the gradient of the tangent, and we need now the gradient of the normal. So the gradient of the normal is the negative reciprocal, which is negative 4 over 57. Okay, so now what we need to do is we will use this gradient, and we will write out the equation of the tangent. So we get 57x minus 4y, and then I will evaluate that when x is 4 and y is 18, as we found earlier. And that gives us 156. And therefore the equation of the tangent is 57x minus 4y equals 156. And now for the equation of the normal, I'll use that gradient, and so the form of this will be 4x plus 57y, and then I'll evaluate that at 4 and 18. And so we get 16 plus 1026 when I multiply these, so I get 1042. So therefore the equation of the normal is 4x plus 57y equals 1042. So these two equations may not be in the form that you're used to or you're accustomed to, but all I have to do is either rearrange the equation for the y term in each of them, or isolate for the y, and then you'll get these equations into the forms that you're more familiar with. Okay, so that is the end of example 1. We'll now move on to example 2. Okay, so now we go on to example 2, and we're going to find the equation of the normal to this graph, this function y equals 1 over sine 2x, at the point of x equals pi by 4. Well, because the normal is linear, we need a gradient and a point. So we've got x equals pi by 4. I can evaluate this function at x equals pi by 4. So then I can actually get the ordered pair that I'll need to evaluate this. So I've got 1 over sine, and 2 times pi by 4 is pi by 2. And I'll just draw a quick sketch of the sine curve, roughly. And so this is pi by 2, and that when sine of pi by 2 is evaluated, that gives us 1. So we end up having 1 over 1, which just ends up being 1, which means that the point, the ordered pair that we're going to be looking at, is pi by 4 and 1. So we have the point at which we will evaluate this to find the normal, the equation of the normal. We now need to find the gradient. And so I'm going to rearrange this, or rewrite this into this form so I can take the derivative a little bit easier. I'll put it to the negative 1. And so then the derivative will be negative 1 times the sine of 2x to the negative 2 multiplied by the cosine of 2x multiplied by 2. I'll just simplify that a little bit. So I'll bring the 2 and the cosine of 2x to the front. So I've got negative 2 times cosine of 2x all over sine squared of 2x. Now the gradient, we need the gradient of the normal, but to get the gradient of the normal, we first need the gradient of the tangent. And that is when we evaluate the derivative function, or the gradient function, at x equals pi by 4. So I'll substitute pi by 4 into the equation. And we see that we've got a cosine of pi by 2 that we need to evaluate. And we also then have, once again, the sine of pi by 2, which we saw earlier. So for the cosine, let me draw a quick little sketch of the cosine curve. From 0 to 2 pi, of course, this is pi by 2. And this is y equals 1. So when cosine is evaluated at pi by 2, it equals 0. So here, when we evaluate the derivative at pi by 4, we see that the gradient is actually going to be 0. So that's all fine and dandy. So we know the gradient is 0. Gradient of the tangent, sorry, is 0 at pi by 4 when evaluated at that function. Now, if we want the gradient of the normal, we know that the normal is perpendicular to the gradient, and if the of the tangent, the gradient of the tangent is 0, that means that the gradient of the normal is undefined. And if it's undefined, that means that the gradient is vertical. So if that gradient is vertical, that means that the normal is going to be vertical to the x-axis. Basically, it's going to be perpendicular to the x-axis. Therefore, the equation, the line is going to be, the normal is going to be cutting the x-axis, and since it's vertical, it's going to be cutting it exactly where, at the x value at which we're evaluating this. So the equation of the normal is actually just x equals pi by 4. Okay, so those are a couple examples to work on for 16A, the supplementary work. Please maybe take a look at a couple of these tonight, and then work on the rest in class. So thank you for your attention, and we'll see you in class.